am ready. Thank you for asking. In chapter 6 and chapter 5.
They were awful, yes.
Chapter 5. Whatever. Yeah. Chapter 5 and chapter 6. You had SOH, CAH, TOA for right triangles. Now, in this chapter, you're going to deal with non-right triangles. That means start writing. I'll give you about 10 seconds to write this down, and I'm going to start talking. You write down everything that's right here. I'll explain that in a minute, but there's way too much talking. Now there's got to be none. So start writing. That is an extended proportion, normally used only when you have similar triangles. However, in this extended proportion, this is known as the law of sines. It's for solving non-right triangles or right triangles. The point I was trying to make earlier, before I was so rudely interrupted, was everything you've learned up to this point can only be used with right triangles. Do not refer to tangents in this, secants, any of that stuff. That's only for right triangles. If you physically see a right angle, you can use SOH, CAH, TOA, or anything like that. Okay? Most of your note card was built on right triangle trig. You can see right now this goes past the right angle. Okay? So I alluded to this the other day with the area for a non-right triangle. But right now, this is how you solve for a right triangle. There is a problem, though, with the law of sines. Okay? So, in any triangle, it says the ratio of the angle to the side opposite is equal to the sine of the angle with the ratio of the side opposite of it. That's how a lot of people look at it. I look at it another way. You can use that picture, but I probably won't. That's in your textbook. That's just next to the title. I always look at the picture like this. A, B, C, small b, small c, small a. That's the picture I use. I use that a lot. It looks like an equilateral triangle, but it's not. The problem is there are 6 parts to a triangle. When you were in the other chapters, you could always count on one angle being a right angle, so that was one of the 3 parts you were given. Fantastic. Then you use the Pythagorean theorem, which we can't use here, and then you use the inverse functions that we can use here, and we were also working on the unit circle, which we aren't using here. So there are some similarities, but there are also some differences. You won't have pi over 6 or things like that. You're going to go back to degree mode now because these are a lot more application-based problems. If you notice one thing about this, you can use this if you're given 2 angles and a side. If you can fill in an angle and a side, you can use this. Remember, A, B, and C have to add up to 180, don't they? That's something else you can use. So given 2 angles and a side, you can use this. In a certain order, of course. Given 3 sides, you can't use this. That would be for the law of cosines, which will come later this week. So there are some restrictions on the law of sines. There's also some people think this is the greatest thing because they never go back to SOH, CAH, TOA. They always go back to this for right triangle trig. You have that option if you want. Obviously if you have a right angle right here, everything is going to be the same as in the law of sines. But the good news is the law of sines is very easy to use. So easy, people think it's just almost scary. Okay? Like I said, make sure your calculator is set up in degree mode And we'll solve some proportions. And you'll see some of the pitfalls that you do with this. For instance, one pitfall right away. When you're looking for an angle, who's like really smart in here with trick? Graham. If I hit the inverse sine button of, say, A over B, on the calculator, when I hit that button, where's the answer going to be? When I hit this button from the last chapter, where is the answer going to be? When I hit that inverse sine button, I'm committing myself to what two quadrants? Okay, he didn't tell you exactly the whole answer. He told you half of it. This is going to be between 90, because he doesn't listen, I said degrees, and negative 90. What triangles does that take out of the realm of possibility using the law of sine? Anything bigger than 90, we have a mathematical term for any triangle with an angle bigger than 90. We call that triangle an obtuse triangle. So obtuse triangles, you're going to have to stop and take a look at before you use this law of sines. How can you tell if you have an obtuse angle versus an acute angle when you're given the sides of a triangle? Remember, the theory that you have geometry credit is still valid and needed at this point. How can you tell if there's an obtuse angle versus an acute angle when you know the sides? People are breaking eye contact faster than I can make it. Oh, no. There's something called the triangle inequality theorem. Abigail remembers it. The largest side is opposite what? The largest side is opposite the largest angle. Largest side is opposite the largest angle. So if you have two sides that you're looking at, and you take the inverse side and the angle turns out to be smaller than the given angle, you know you should probably go to the obtuse angle. Okay? That'll come up and you make a difference. But just remember, the inverse sine, obtuse, could throw it into a problem. Okay? Fantastic. Yep. Sure. The inverse sine, when you take it, has numbers between 90 and negative 90. But we know our triangles can be, have an obtuse angle. Okay? So for instance, if I had, I don't know if this is going to work. I'll see if I can make one up on the fly. Let's say I have a triangle that has 3, 5, and 30 degrees. Something like that. Okay? I have no idea if this is going to work or not, but we'll give it a go. You see how this is like angle A, and this is side A. That makes sense? All right. So if I take the side of A over 5, that has to equal the sine of 30 over 3, right? So far, so good? Mm-hmm. Fantastic. Well, what is the sine of 30 divided by 3 multiplied by 5? Well, blank looks. You have a calculator, correct? Nice! Let's see if they work. So, A equals the inverse sine, what? 5/6. Which is what? What is it? 56.44. And you ask yourself, is that angle really, let's just call it 56.4 for fun, okay? Is this angle really 56.4? Or is this angle actually 123.6? How do you know? What is the sine of 123.6? What's the sine of 56.44? So they're pretty close, aren't they? But how do you know which it is? It's opposite the side, isn't it? You'd say the smaller one? It's the bigger one. You have to have some reason, some mathematical reason for your conclusion. How do you know which one it is? It is opposite the bigger side, but you only know two of the sides, you don't know the third. Wait a minute, say that one more time about 180. Okay, what's 56.4 and 30 subtracted from 180? 56.4, 30, and what'd you say you get? Says what? 93.6, 3, 5. Could that angle be 93.6? Sure it could. Why not? You don't know what this side is. What is this side? What is this side right here? No, there is no hypotenuse. There is no right angle. The law of sines. Thank you. Thank you very much. Let's see. Let's call this C and call this C. So, C over the sine of 93.6 equals, huh? Oh, because A over B equals C over D is the same as B over A equals D over C. 1 over 3, 3 over 9 is the same thing as 3 over 1 and 9 over 3. You can have the sines up here, or you could have the sides up here. I always fall into a habit. I put what I'm trying to look for in the upper left. That's my habit, sorry. Yeah.
How do you know which angle to use for that?
You always use the side opposite
No,
and the angle.
93.6, because we don't know if it's 123 or 56.
I know, so we're using 56.4 right now to see if it works. So I'm going to call this, well, it doesn't matter what I call it, I'm going to do 5 over the sine of 56.4. What does it equal? What does it equal? There you go. So what is it? Let's go one decimal place. 5.9. That works. That side's bigger than this one. Wait a minute. There's another possibility. That could be 123.6. 5, 30, and 3. What's that side going to be then? 26.4? Is that possible if those three add up to 180? Is it possible that's 26.4? Sure. What is this going to be then? Yeah, it's going to be less than 3. Because 30 is bigger than this, so now it's going to be the small side. Over here is the biggest side. I know, this is great. So we got, I'll call it C again, how's that? C over the sine of 26.4 equals 5 over the sine of 123.6. What is it? 2.7. What is the deal? How come it can give you two triangles? In college, I go to a different explanation right now than I would in high school. High school, I go with this explanation. This is why you can only use side, angle, side, angle, angle, side, and side, side to prove two triangles congruent. This one shows why you can never use the side angle approach for proving triangles congruent. It's known as the ambiguous case. So when you have the side, when you're given a side-side angle, there's a possibility with the law of sines, and this is the trouble spot, there's a possibility that you could have no answers, one answer, or two answers, depending on how the mathematics works out. Is this true every time you're given two sides and an angle? Absolutely not. If you're given two sides and the included angle, like in this situation, if you're given this side, this angle, that's how you can prove triangles congruent, right? Side angle side, that means there's only going to be one answer. Or if you're given an angle side, one answer. Because that's how you prove triangles congruent. But you were never able to use side angle. Obviously in college you know what I do differently. But side angle, you can't use that to prove triangles congruent. That's why. Okay? What? It's very colorful actually, but not intended for recording purposes, obviously. So, anyway, that is the one sticking point for the law of sines. It is known as the ambiguous case. Ambiguous. Is that spelled right? Side angle. The law of cosines has an automatic fix for this. We'll get to that later. The law of sines, the only fix is a lot of hard work. Okay? How do you know when that's the situation? When you go through your markings and you're given side angle, you got to think to yourself, uh-oh, could be a problem. Is every problem going to be like a side angle? Well, absolutely not. Remember, this means B, this means C, and that means a capital B, right? If I draw my triangle, remember, I always draw the same one, usually. A, B, C. Or I might not label it correctly, but if B is 20, C is 31, and B is 210. Is this a side angle situation?
Nope.
Absolutely not. So how many answers are going to be?
No.
One. Could you prove two triangles congruent with angle side in your statements and reasons? Yes, you could. That means there's only going to be one possible triangle that's going to get as a result. So, the easy part. What's A? 129. On these parts, I try to live up to the expectations I told you before. I only try to use the given to find everything else. Sometimes you have to use your result to find it, but I try to avoid that as all possible. So what do you want to find first? Small a or small b? I know capital A, the measure of angle A, equals 129. 3 solutions for each problem. I love this. 3 givens, 3 solutions, piece of cake. We already have small b. Oh, sorry, I'm looking for small c. You know for small c? Sounds good. Small, I always put what I'm trying to find in the upper left. You do not absolutely have to do that. It's just a habit I got into when I did some higher mathematics as an undergrad when I was doing proportions. So I put the sine of 31 equals, see, 210 over the sine of 20 degrees. See, all you have to do is take the sine of 31 times 210 divided by the sine of 20. Usually go to one decimal place. Does everybody know that you can write A over sine of A, B over sine of B, C over sine of C? You can reverse that, right?
Yeah.
Okay. I mean, you can write the other way like I did here. All right. What'd you get for C? 316. 0.2. .316. Now, can you use the Pythagorean theorem? No, you cannot. All right, you ready? Now, obviously, A should be the biggest side, correct? Let's go on and see what we come up with. What is it? Oh, that's a mistake. I'm nervous. I don't know. Got a lot going on. It's like a slot machine up here right now. Hey, isn't there something easy to use? I'll tell you what most students do in your situation. They learn the law of sines. They find a couple things. They go back to the law of sines when we start doing at-large triangles. Right now you're doing triangles that only fit the law of sines. When you get at-large triangles, you have a choice. Law of sines, law of cosines, or to give up. Okay? So, with that being said, 210. Let's see how many people remember to just go back to second and entry and change their last one to sine of 129 times 210 divided by the sine of 20. Nobody remember to do that? Oh, we can. And what do you get?
477.
For what?
477.
0.2. All right. This is something that's very easily programmed, but you can play around with it when it comes time for the test. Don't have it on there. Okay? Very easy to program. A lot of people did it last year. A lot of fun to play around with it. Huh? Huh? Yeah. I mean, have me do it? No, I've done it before. I'm past that point. Okay? Nice. Solving the triangle means find all the missing parts. Okay? This is obviously decimals, so if the angle goes to 2 decimals, your angle will go to 2 decimals. Sides at 2 decimals, your sides go to 2 decimals. Actually, it's supposed to go to 3, I believe. Something like that significant figures rule, but here we go. I wouldn't say completely irrelevant, but I don't really go by that a whole lot. So C is 27.19 degrees. Sorry. Yeah, A is 103.45 degrees. What's B going to be? What is it? Small b is 38.84. That's okay. Now, is this given to you in a side-side angle? Ambiguous case.
Nope.
Angle, side, angle. Can you use that to prove triangles congruent? Yes, you can. That's one of the 5 non-right triangle ways. Wait a minute, one of the 4. There's actually 4 non-right and 4 right, correct? There's side, 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 angle, 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 side for the non-right. For the right, there's HL, LL, HA, and LA, right? Okay. So, what do you want to find first? Capital B. What does the measure of angle B? Obviously, you took 180 minus 103.45 minus 27.19. That was fun. Makes you feel good about yourself. You got 1 out of 3. You want to find small a or small c next? Small a. A over the sine of 103.45 equals, let's see, 38.84 for the sine of 49.36. Obviously on this one I have to use something that I found because I don't know the other side as well. How you doing? Nice. Thank you very much. Where's that at?
Take care of it.
Where's it at? Nice. I'll probably just throw it away now. You know how kids are. What do you get when you solve for A? For what? 49.78. Oh, pretty good?
Yeah.
Is everybody doing okay, or are you getting frustrated? Piece of cake? Great! Great. What is C? 23.39. All right, do I have to go through how to set it up? All right. All right, we're doing well. Everything okay? I'm getting some looks like some people aren't quite sure what's going on. Rain break? Who said that was going on? I did? I started, huh? All right, I'll see if I can find one real quick. Let's see. If I can't find one real quick, I'm going to quit.
No retreat, no
Well, it's not retreating or surrendering. All right, this has to be quick. We haven't done a partner one. Let's try one of those. Oh, there we go, partner. We did the. Oh, wait a minute, we already did that one, but we'll try it again. We've never done this one. Did it copy? I'll find out. Oh, we haven't. All right. Oh, we did? All right, good. It's a good one. Oldie but goodie. So, stand up and find a partner. Decide who is A and who is B. Person A should do this. Try to clap but miss. Put your thumbs down. Clasp your hands together. Pull your hands inward, rolling them towards you until the hands are on top of your elbows near your side. Now, person B should point a finger to person A. Don't touch their finger. Now, person A should wiggle the finger that was pointed at. Okay? And do this for 4 different fingers. And then try to do a thumb. Okay? I point to you. You can also point the thumbs. Make sure you switch and both people do it. Yeah. Okay. Huh? Meeting. All right. To determine the distance between 2 points, A and B. This question is always on a final exam. 1 is see if you can label the information. 2, see if you can read the information. 3, see if you can solve the question. They don't give you a picture, nor will I give you a picture. To determine the distance between 2 points A and B, a surveyor chooses point C, A, B, C.
Why'd you put the B over there?
You don't have to. You can change it. To determine the distance between A and B, X. Surveyor chooses a point C. That's 375 yards away from A and 530 yards from B. The measure of angle BAC has 49 degrees and 30 minutes. That is 49.5. Approximate the distance between A and B. I would caution to anybody who says it's easy. Why is it not easy? It's the ambiguous case. Side, side angle. So, with that given, onward to find X. Can we find X right away? No, what do we have to find first? Angle B, we have to find out first, don't we? So, first is for angle B. Now, well, I think you'll figure it out. I'm not even going to tell you. Is angle B, can angle B be obtuse or acute? Angle B, does that have to be acute, obtuse, or could it be both? Right, angle B has to be acute in this situation because it's not longer than 530. On the one we did before, the 5 was opposite the angle we were looking for. So you didn't know if 5 was the biggest side or if it was going to be the medium side. So right now we know just by looking at it, you can tell ahead of time how many answers you're going to have in the ambiguous case. In this one, the side opposite is smaller, 1 triangle. We're in good shape. So I hope, anyway, that the mathematics supports it. So we got the sine of B over 375 equals sine 49.5 over 530. Don't forget to use the inverse. And we should be able to stick with the acute angle. All right, what do you get? 32.5? All right, so B is 32.5. That helps us because now we know exactly what this angle is going to be because there's going to be one possibility for B. And somebody says, well, why can't it be 147.5? Well, if you put down 147.5 and added 49.5 to it, it's too big. It's already past 180. Okay? There's another way of looking at it. If you take the other possibility and add to the existing angle, and it goes past 180, that also tells you there's only going to be one triangle. So you can either look at the sides, or you can look at the angles. Both of them support the fact there's only one. So what is angle C going to be then? Let's see, 70, 80, what is it? 98 even? Nice. So, X over sine 98, which means it's going to be the biggest side, correct? Right? X over sine 98 and 530 over the sine 49.5. What's it turn out to be? 69.2? 69.2, which is in yards. I gave this question one year. It's been about 4 years ago now. I just saw the individual at Parkland last summer. And anyways, about 3 or 4 years ago, guy said, that's what I want to do. I want to be a surveyor. I said, great, Trig's perfect for you. In fact, I'll get a guy from Champaign come out and give you a surveying test. If you do well, you can get a scholarship. They'll pay your way. Really? Sure, the guy came out. There was actually 4 or 5 people that signed up for the test. So we watched a little video. We took the trig test. And I just saw him. He's still working on it. He's actually going to Southern Illinois. Last fall he was supposed to go, I think, or this spring, one of the two. So if anybody's interested in surveying, I can make a phone call. A guy will come out, give you a test, and see how well you do. People in Champaign take it. People in Urbana take it. And sometimes we take it.
A surveyor.
Yeah. Okay. Actually, they also measure heights. In big cities, they also measure how tall things are for property taxes. Okay? Yeah, a lot of three-dimensional surveying, I think is the way he called it. Ha! This question is here for one reason. This is a question the guy ahead of me couldn't answer in class one day when the students asked him to do it. He became very frustrated and said the question couldn't be solved. So I picked it, see if we could. A straight road makes an angle 15 degrees with the horizontal. About time? Ooh, yeah. But the angle of elevation of the sun is 57 degrees, a vertical pole at the side of the road. Look at this. This is awesome. Vertical road casts a shadow 75 feet long directly down the road. Approximate the length of the pole.
I don't feel like this image is here.
Green.
That's 75.
75 feet is the length of the shadow of the pole. So there's a shadow. That's 75.
Oh, so that's that.
Wait a minute, I just see something else. If this line is parallel, wouldn't that be 15 degrees also? I don't know if that helps. It doesn't?
Oh, yeah.
Okay, just checking. All right, we got the pole.
No, because that is
What's 57?
57 degrees is the angle of elevation of the sun is 57. So that whole thing is 57, right? So if this whole thing is 15, that means that angle is going to be 42? Ha ha. 42 degrees.
And we have 75.
Yeah? How do you know this? Correct? These two? Yeah?
So, like, I forget what it's called, but when it flips over thing.
It flips over the thing.
Like, I'd have to draw it. I can't remember.
Well, I agree that this is 42. That's fine. Are you sure it's 132? Huh? 105? I might buy that.
How do you get that, though?
I asked Alex, he told me it was 105.
The house you get that.
Yeah, I do. He's going to come up and show you. Yeah.
So when you have two parallel lines, and then you have this, these two angles are congruent. So that's what this is, and this is. And this is 90, so 90 plus 115 is 1. Complementary? Yeah. Supplementary?
Can't see
No,
your
it's
body,
this one.
Alex.
It's this one. It's this one.
Alternate interior angles.
Yes, alternate interior.
I don't see the parallel.
This
Oh.
line is parallel to this line. So then this angle is connected to this one. So 15 here is 15 right here.
Plus what?
90. This is the 90-degree angle. And then
Because it has to be perpendicular to the base.
because it's a straight line and a straight line.
Yeah.
So that's
Nice.
90.
Thank you very much. What's wrong? The word problems in this section? I know, they're fun.
This topic is 33.
15? I know, it's fun. This is also 15. I think he was saying that makes
Yeah.
this 15,
Yeah.
which makes that a right angle. So that makes it 105. Very nice.
That is the 33.
Top angle is 33. But we need a 75. Remember where the 75 comes from? 75. That's the casting of the shadow.
Four of we labeled pictures.
Thank you.
No, not that one. That one. The one that gave us.
Oh, yeah, I know. You got to dig through it. Somebody said there's a few more of these in this section. I'm very excited.
So then you just
What do we need to find?
We need to find the pole. So the pole is equal to the sine of 42, which equals the 75 over the sine of 33. I know, we were just talking about geometry yesterday. It's great, isn't it? All that alternate to your angle stuff. And what do you get?
92.14.
Nice, 92.14. So the pole equals 92.14. Meters or feet? Feet? Nice. Anyway, go ahead and get through 21. And page what? Page 537? Page 537.
They give you my physics.
Oh, Mr. Barron's?
Yep.